Hi, this is Nick. I'm the TA for microprocessors, and this is a tutorial for Lab2, the in-lab assignment. The in-lab assignment was to add the numbers between 1 and 100. To start, I'll tell the famous story about Gauss, where his teacher asked him to add the numbers 1 to 100, and he quickly came up with the answer 50-50. So one way to do this quickly is to add 51 plus 50, and then add 49 plus 52, and so on, 48, 53. And starting in the middle, you find that they're all equal to 101. So 101 50 times, it gives you 50-50. So you might intuit that 1,000 will give you 500, which it does. And so we'll switch over to programmer mode to find out what that would be in hex or binary so that we know what to look for when we get our solution. Also, this helps us size up the problem. So this is occupying, this is the word length, 8 bits, so that's 1 register, 2 registers, and the 3rd register. So this answer will require 3 registers to hold. Furthermore, the value 1000 will require 2 registers to hold. So as I create this project, you might not be able to see the window, but I'm selecting AVR assembler project, and I'm going to click browse here at the bottom. Instead of saving in the default directory, don't do that. Put it on the desktop or something and have it create a directory for you so that you know where to find all your stuff. You don't have to go hunting. And then 644A, which I think everyone's familiar with by now. So we get our code up here. From the textbook, we can copy the code that's an example. This is using Foxit Reader, and the indentation gets screwed up, and also we can see this include line gets screwed up, but overall Foxit Reader did a pretty good job. The M250 or 2560, that is not our microcontroller. The 2560 is similar in architecture, but we don't need this line because that library is not relevant to us right now. So the first thing you want to do is run your program to make sure that it's working just like that without making any changes yet. So first we need to make sure we have our simulator selected in our debug tools. You can save that setting and then go ahead and start debugging with breq, the play plus pause button. Now it'll pause you at the first line, and we can walk through by clicking the step into button, and it'll just continually go through. Since we know this is going to happen 100 times going through this code, we can pick a good point to pause, for example at the done part, and just press play and it'll stop at this breakpoint. First of all, just looking at this program, I'm going to want to have some white space by my sections in order to be able to read it better. I'm going to change from 1000, instead of looking at it in decimal, I'm going to, in my code, place it as a hex number. So that would be 0x. And I'm going to add another definition, a couple more definitions for the index and also for the answer register that's going to hold the answer. So I'm also going to want to load the number 1 into a register just so I have it. I could use an immediate value, but I'll just do it this way. Now the reason why I'm using the number 1 from another register rather than increment here is because increment will never trigger the carry. So we need to know when we've passed the first register so that we can overflow it into the second register, which will be R20 here, index 2. So just like it uses here in the example add carry using R25, which holds a value of 0, it was initialized to 0. So that's just a way of counting carries. So every time this overflows, we can just dump the carry flag and reset it also this way. At this point we've made several changes, so now let's try building and see what happens. So we get this error that I know some people got in trying to write this. Operand out of range because, well, obviously this number is too big to fit in one register, so we can't really compare this immediate value with an 8-bit value. It's not really going to work. So I'm showing you some bit manipulations here, and I'll step through and show you line by line. So this is loading, for example, just so you can see it come up in the memory viewer. R27 is receiving the value of 1000 bit shifted right by 8 times. So what it receives is just the top 8 bits, because we shifted the bottom 8 bits out of the frame, so they're just gone, I don't know where. And then so we can also use a similar trick by using a bit mask, an AND operation. So we can just throw out the top by ANDing it with FF, and then it'll receive 8. Equivalently, you can use a binary bit mask if you don't want to think about it in hex, which is sometimes useful. So this definitely isn't the most elegant implementation, but it is one that works. So it first checks the lower half of the index. If that's true, it'll go ahead and check the top half of the index. Now, in the addition, it adds to the low byte, it does the overflows, and then it'll add the middle, and then overflow that, and then it'll increment and overflow the index. So this is a working solution, and if you go to done, it'll show you in 17, 18, 19 is where we stored the answers, and that is the answer. So that was my take on the problem, and if you have a better code solution, post it in the comments, and I'll post this code, and then this will help people to get a handle on assembler coding. So thanks for watching.